So we're looking at the graphs of tan. So they will do the graphs of tan. And cot. So we did the graphs of cosine, sec, sine, cosec. So now we do the last piece of the graphs, tan and cot. The general form, of course, is this one. A tan bx plus c plus d. And everything else the same apart from the period. Here the period is pi over b and not 2 pi. And then the amplitude is still the same, though here the meaning of the amplitude is not how high it goes, but it's just a stretch. I'll demonstrate how that one is. And then what else? The horizontal shift is the same. You get to 0. The vertical shift is the same d. And finally, the scale here also changes a bit. It's now the period over 2. It's no longer 4. The reasons are very simple. Let's go to the example. Sketch 1 f of x is equal to tan x. Remember we said that if you're sketching and you don't want to use the shifting method, you want to use the table method, then all you need to know is the period. So in this case, it will be pi, which is 180. And then what is period? Then we'll have what is important is the horizontal shift. So in this case, it's 0 because you're saying x is equal to 0. Then now we go to the scale. And the scale is 180 over 2, which is 90. So we can form a table. Remember, so we'll sketch this one from 0 x 360. So we'll form a table, the x values, and then f of x. So on the x values, we're starting from 0, and then we're adding the scale, 90, and then you add again 180, and then you add 270, and then you add 360. Like this. F of 0. What is f of 0? We're talking of tan 0. And tan 0 is 0 because tan is sine over cos, and cos 0 is 1, sine 0 is 0. So this is 0. F of 90. This is like sine 90 over cos 90. You know what happens? Sine 90 is 1, cos 90 is 0. So this guy is undefined here. And then the next one will be 0, undefined, and then 0. So, you know, all the zeros of sine, wherever sine is 0, tan is 0. Whenever cos is 0, tan is undefined. And so the sketch then becomes an easy thing. So we'll have 0 and then go to 90, 180, 270, 360. Then where we are saying undefined here, we have what we call asymptotes. So these are asymptotes. Undefined, they are asymptotes. And then tan takes so let's see the orientation of tan. You know, here between 0 and 90, we can find 30, we can find 45, and we can find 60. So that you see what is tan 30. Tan 30 is half over root 3 over 2, which is 1 over root 3. Then tan 45 is 1. Tan 60 is half. Tan 60 is root 3. Is root 3. So you see what is happening? As you move from 0 going to 90, tan is increasing. So you have this behavior. And when you place the amplitude here and down here, and this guy will come, and reaches here, it will turn now going to the line. So it will come, when it reaches 1, it will turn going to the center, come down, and it reaches 1, it will go down like this. That's what happens. And then meaning that here it's just starting from there. When it reaches 1, it will go down like this. So this is how you sketch the graph of tan. There's really nothing much on the graph of tan. Hello?
Sir,
Yes?
kindly repeat. My network was breaking, so I didn't get anything on that.
So we're saying tan has got this general form here, where the period, there's a difference between the period of tan and the period of sine and cos. The period of tan is 180 over b, which is simply pi over b. And the amplitude of tan is to the amplitude, the way you used to get it. The horizontal shift, the vertical shift. What will change again will be the scale. For sine, cosine, and the other two, the scale was period over 4. But for tan, cot, the scale is period over 2. So we have an example here. F of x is equal to tan x, where our a is 1, our b is 1, our c is 0, and our d is 0. So period is going to be 180 over 1, which is just 180. Horizontal shift is 0, vertical shift is 0, amplitude 1. The scale is of interest because just want to sketch. So we have period over 2. As we said, you divide the period by 2. So we get 90. Always we start from the horizontal shift. So horizontal shift, we put a 0 here, and then add the scale 90, add the scale 90, add the scale 90, up to 360. Then tan 0 is 0. Tan 90 is undefined. Tan 180 is 0. So for tan, once you use the scale, you just calculate like 2, because 1 will be 0, the other one will be undefined. Then they'll keep repeating like that. So this is 0, this is undefined. 0, undefined, just like that. And then where it is undefined, we have asymptotes there. Where it is 0, that is the center in between the asymptotes. And then tan takes this behavior. This is the orientation of tan, following these angles here, because at 30, you are getting 1 over root 3, at 45, you're getting 1, at 60, root 3. So it's going up like that. Can we give another example? The second example would be f of x is equal to cot x. For cot, the period, the same 180. So I want to sketch again from 0 to x to 360. And then amplitude, same. So we go to horizontal shift. 0, the scale. The scale is 180 over 2, which is 90 again. Question from Kasongo.
Yes, I didn't get the question. You said what was the question?
Sketch f of x is equal to cot x.
All right, thank you.
Okay. Then we form a table starting from the horizontal shift. We have 0 there, and then 90, 180, 270, 360. And then this is x. Then f of x is there.
Yeah.
Then we start. What is cot 0? Cot 0 is undefined. And cot 90 is 0. The other one undefined. Remember, this one is of 2. Undefined. Then you sketch. The first one is 0, then 90, then 180, then 270, and 360. Then you start. At 0 is undefined, so you put an asymptote here. At 90, it's 0. At 180, it's undefined. At 270, it's 0. And undefined at 360. Then for cot now, the orientation differs. For cot, if we put, let's put 30, let's put 45, let's put 60. So we start. Cot 30. Cot 30 is cos 30 over sin 30, which is root 3 over 2 over half, which is root 3. So we have root 3 here, we have 1 here, and we have 1 over root 3 here. So it's going down as we go this side. So just a minute. Okay, so as you can see that as we go to 90, the numbers are decreasing. So this means that orientation of this one is like this, where this is where there's -1, this is where there's +1. The same thing will happen here. Like that. So Cot to take this orientation and Tan will take the opposite orientation. So this is the 30, 45, 60 is just to guide you in case you forget the orientation. You forget whether you have to draw your lines like this or they have to be like this. So to check which one you get, you can use these angles because they will tell you, oh, this one is decreasing, this one is increasing in that direction. I hope it makes sense. So we're saying the orientation here is, the issue of Cot. So if you understand Tan, then you know that for Cot, you just come and do the opposite. How is the opposite done? Where we have zeros for Tan, Cot will have asymptotes here. Asymptotes here. Where we have asymptotes for Tan, Cot will have zeros here. And then the curve also, for Tan, if it comes this way, then Cot it will come the opposite. Like that. That's why I can see that it's very, very easy to draw. Now see the one which has a shift. Let's do the one with a shift so that you can see what is happening. So the one with the shift. Wow. 3 f of x is equal to 1 minus 2 tan 2x minus pi. So this is minus now. So we do our thing. The period is pi over b, and our b is 2. So that's our period. Horizontal shift is 2x minus pi is 0, implying that x is pi over 2. And then the scale is what we need now. Period over 2. So we have pi over 2 over 2, giving us pi over 4. And then a table. So sketch from pi over 4, from pi over 2, that's equal to x, that's equal to it's equal to 2 pi, I think. Yeah, let's do something like that. Okay, so start x here, and then pi over 2, and then add the scale, which is pi over 4. So this is going to be like 3 pi over 4. And then this will be pi. And then 5 pi over 4. And then 3 pi over 2. And then 7 pi over 2. And then 2 pi. Then we calculate now. We put f over x here. Then we get the first value. What is f of pi over 2? So we'll get 1 minus 2 and 2 by pi over 2 minus pi. This will be 1 minus 2, and these 2's will cancel, and pi minus pi, that is just 0, and tan 0 is 0, so we get 1. So we have 1 here. So it means the next one is going to be undefined, but we'll prove so that we don't guess. 3 pi over 4 is equal to 1 minus 2 and 2 3 pi over 4 minus pi. So we have 1 minus 2 and 3 pi over 2 minus pi. This is 270. So we get 1 minus 2. 270 times 90. Times 180, we get 90. So we have tan pi over 2. And tan 90 is undefined. So this is undefined here. We just wanted to prove because we already know. So this will be 1 then. This will be undefined. This will be 1. This will be undefined. And this will be 1. So there will always be only 2 values that we're getting if we use a scale. So you get 1, or you get whatever number you get here, then undefined, that number undefined, that number undefined. Then we can sketch. So say the sketch. The sketch is going to be pi over 2, 3 pi over 2, pi, 5 pi over 4, 3 pi over 2, 7 pi over 2, and 2 pi. So we have undefined lines where undefined lines on 3 pi over 4. Again, you skip 1, the next one is undefined, skip 1, undefined, then 1. So this one becomes like our middle line. So we just keep in mind that at 1, that is where now the 0 line is. Because you're not getting n zeros. So it means here that's where we have the intercepts, because we are getting 1s here. And then, well, we have tan. So let's see what happens. 30, because now it's negative. So we don't know the orientation. So let's put 30, 45, and 60. So if we do f of 30, that will be 1 minus 2. Tan 2 minus 30, that is 60 minus 180. So we're getting 1 minus 2 tan negative 120. Then if you bring that 120 outside, you have 1 plus 2 tan 120. And because 120 is in the second quadrant, we know that this angle is going to be negative when we get it. So tan 120 is the same thing as tan 60, but tan 60 is 3. So it's going to be 1 minus 2 by root 3. Then let's get tan 60. That would be 1 minus 2 tan 2 by 60, that is 120 minus 180, we get minus 60. Then take out, so we have 1 plus 2 tan 60. Oh, so we're getting these values outside the interval of our sketch. Yeah, outside the interval. Yeah, so it's outside the interval, but still we'll pick 1 or 2 things there. So this is tan 60, so we'll have 1 plus 2 root 3. So what we are saying is, if it was 30, it's below, and then 60, it's above. So this one won't give us any information because it's below. But then what is key is if you have a minus outside here, then you take the shape of cot. It will look as if it's cot. So it will go like this. It will be going like this. So it will be going like this. It will be going like this. And then the amplitude is 2. So it means that you want it to be doing that shape at 3 and at -2. So these won't be that much visible because for tan, really, they are not that much visible. And because of the nature there. Okay, so unless there are questions. So the meeting will be cutting, so we chill a bit for like 10 minutes. Just hit my battery bit. Then we'll join at 1846. So we'll just join at 1850.